Hello, students. 2 sections to go. We're into section 7.4. This section is on percents. And when you think about percents, most of you have a pretty good idea. You've seen them before, you've used them before, but this is from the Common Core. We've got in grade 6, expected to accomplish the following: find a percent of a quantity as a rate per 100. And that's actually what percent means. So when you think of like 20 cents, we're thinking of a portion of a dollar. And even the word cent, think about other words like centipede, right? Or century. These are all words that kind of reference 100. Centipede is 100 legs. Century is 100 years. So the cent stands for 100. So when we say we have 20 objects for each 100, we've got a ratio then, a ratio of 20 for each 100. Now, sometimes we'll shorten that for each to say per, like miles per hour. So 20 miles per hour means 20 miles for each hour. We say 20 per, and then per 100, remember 100 stands for cent. And so we actually have the words 20 for each 100, and we just kind of combine those to make 20%. Now, the symbol for that, percent, would mean per 100. So it would be like 20 over 100. And over time, this little symbol with the slash, we knew it was 100, so they would just write 2 zeros. And then to make it a little bit separate, so you didn't think of it, entirely as a fraction of itself, we kind of wrote them separately, a 0 on top and bottom of the slash. That's where that symbol comes from. So the per 100, that little symbol comes back. So our definition of percent is simply that. N percent means n over 100, and n is any non-negative integer. So 0% is fine, but that's what percentage means. Now, you could have a decrease of 20%, sure. So we could think of a decrease of 20%, but again, that's just kind of moving up or down on a particular number. All right. Let's see here. So if you're working with students, you'll also come back and you'll see these 100 grids. A 100 grid allows students to shade a certain amount. However much they have shaded, because it's on a grid out of 100, is also a percentage. So you can think of this one right here as 3 big 10 blocks would be 30 out of 100. You could write it as 30 over 100. So you could write it this way. And then realizing that 30 over 100 is equal to n%. This would be 30%. Bada boom. All right, so let's take a look. Again, some grids that you can utilize visually. That also means if you want to convert a fraction to a percent, turn it into a decimal over a decimal fraction that has a denominator of 100. So 3/4, build that thing up to have a 100, and there you go. Now, just be really careful. A lot of times students will make this mistake. This is one that's fairly common, not just with college students, but also with students learning about this for the first time. If you say 3/4%, a lot of times students will read that as 3/4 as a percent, which is not the same thing. 3/4 would be 0.75, as a percent would be 75%. But 3/4%, see, that's less than 1%, and 1% would be 0.01. So 3/4 of 0.75 with a percent would actually be 0.0075, again, being less than 1%. So be careful, think about the number you have, and then again, percentages per 100. So some of the questions here will say, write the following as a percent. If there was an issue that occasionally that I see, it's students struggling to find the exact percent form. for some of these values. So what you'll see down here is the way that they have chosen to write these in terms of percent. And so let's talk about a couple of those. Again, many of them are pretty quick. If you have things that are in decimal form already, anything that's a fixed decimal form, probably here A through F, those are going to be pretty basic. 0.03, if you read this, it'd be 3/100ths. 3 over 100, 3 per 100 is 3%. 0.3 repeating, if you think about that, 0.3 repeating. If you multiply to get a denominator of 100, you would have 33.3 repeating because you'd multiply by 100 on top and bottom. And percent-wise means 33.3 repeating percent, again, because I have the percent representing the per 100. Okay. Let's see here, 1.2. Well, 1.2, again, I need to write this over 100. So I put 100 on the bottom, multiply by 100 on top, I get 120. So this is 120%. Okay, very similar. So all of them, what you're doing, you're getting this nice little pattern. When you get down to the ones where they don't terminate, well, yeah, they don't terminate, or it takes a while for them to terminate. It can be a little bit more challenging. But just think of how you can convert those. So let's take a look here at the one they did here is 2 1/7. There's nothing wrong with that. They multiply the top and bottom by 100. 7 times 2 is 14, plus 1 is 15. You multiply by 100, you get 1,500/7. And so this would be just fine percentage-wise. Most of the time it's easy to see. Well, let's turn that back into a nice mixed number, because it's usually a little bit easier to say. It's a little bit over 200%. And so you divide it in, and you can turn it, basically converting from a mixed number and improper fraction, just like we did before. So let's try one more together. Let's do 3 5/9. Okay. So 3 5/9. Let's do this one a couple different ways. Actually, let me get a little white space in here so that I can work and not worry about my spacing. Okay, 3 5/9. That's what we want to do. We want to turn this number into a decimal, actually into a percent. So here we go, 3 5/9. Option 1, 3 5/9. Option 1 is to convert this into a repeating decimal. Okay, 3 5/9. What does that turn into? 3 5/9. When I convert and I do 100, I basically floss this with 100 on top and bottom, becomes 355.5 repeating. So as a decimal, I get 355.5 repeating percent. Again, look at this. When you see the per 100, you can write that as a percent. And then you can choose. You can rewrite this as 355 5/9, because that's the 0.5 repeating. So you can choose which one you want. Both of these, they are equivalent. One is a fraction form, one's a decimal form. Okay. So now let's try way number 2. Way number 2, take the fraction as it is, convert it to an improper 27/32. 32 over 5. Now rewrite this over 100. So when I rewrite this over 100, I get 3,200 over 5, right? Oops, over 9. I don't know why I put 5 there, over 9. And so now 9 goes into 3,200 how many times? So now I'm going to rewrite this. So 9 goes into 3,200. Let's see here, 0 times there. 3, which is 27, is 50. 5 times 9 is 45. That gives me 50. 5 times 9 is 45, which gives me 50. And I keep going. 0.55555, repeating. I get a repeating remainder, so I have it. So this turns into 355.5 over 100, which again, 355.5 repeating percent. Okay. Now, hopefully you notice the first one is great. If it turns out you've got a fraction that you know the value of it, you can leave it alone. Notice over here, I wrote this as a continuing decimal. You could have stopped right at this value and taken the final remainder and rewritten this as 355 5/9. And that would have been your percentage here. They are equivalent. So if you happen to know the decimal form for some of these, great, use it. But if not, sometimes it's harder, it's longer to take that time to go convert and find the decimal. In this case, for 5/9, that's not true. But if it was 5/7, that's going to take a while to write the repeating decimal to figure out what I do to move it and to see what remains. So just be careful as you go through and do these. I'd recommend that at times at least know both techniques, and you can choose then which one you think is going to be better. Okay, so that's converting. So taking fractions or decimals and turning them into percents, and of course taking percents and turning them back into decimals is what we're going to cover next. You got to be able to go both directions. So 5%, again, I want you to get used to this idea. 5%, I just write it as 5 over 100. 6.3%, 6.3 over 100, and then I convert it to a decimal. 100%, write it over 100. 250, write it over 100. 2/3%, write it over 100. And then you can turn that back into a decimal number. Okay. Each one of these is very, very common. Being able to do both is critical. So you will have kind of a little chart like this. This is a good homework one to do. I give you a percent, you find the decimal and the fraction. I give you a fraction, you find the decimal and the percent. I give you a decimal, you find the percent and the fraction. So as you try some of these, your goal is to kind of become more familiar with them. If you have a decimal of 0.5, you know that that's 5/10, which is the same as 1/2. As a percent, moving the decimal would get you 50%. So we can go either direction for both of these. Let's see, 36. So 36%, again, you could write as 0.36. You could have jumped over here and done the fraction part first and written it 36 over 100, and then just read that. That's 36 hundredths. Oh, hey, there's my decimal, 36 hundredths. 2 zeros, 2 decimal places. Okay. All right. So forwards and backwards, kind of good skills to have. Nice little school book page with percents. And let's see here. So now we're talking about applications. So applications, this is where I think maybe some of you would be like, oh no, because it's going to be word problems. Okay, so we're going to talk about a few ways to do it. We're going to have an algebraic approach, a ratio approach, and then we're going to use what's known as a percent bar. So there's 3 different strategies. These are used in realistic world situations. Interest, when you invest money and earn interest, or when you have to pay interest on a credit card or a loan. Taxes, tips, discounts at a store, percentage of increase or decrease, like on your salary. So again, a lot of different things where you'd have percentage increases or decreases. So application problems, they usually take 3 forms. And, and that's because if you think of these, I'm going to show you how I think of these as a ratio type of setting, because I think that's kind of helpful. So let me get a new page. So if we say 20 is what percent of, what do we want to say? 50? Okay. So when you look at this, this question is giving you some kind of ratio, right? 20 is what percent of 50? Okay. So the of is telling you what things are out of. So out of 50, you have 20. What percent is that? So you could write this as a beautiful ratio. So I have 20 to 50. The question is, what percent? Now remember, percent always means per 100. So you could say what percent, and you could write a P up here to represent the percentage. And then you could go through and solve this like you normally would. This is proportional reasoning. It just happens to use per 100, which is percents. So that's one way to do it. Now, if you could do this one. There's many ways you could do, because this is two ratios set equal to each other, you could cross multiply, because really you're just finding a common denominator, setting numerators equal. You could just multiply by 100 on both sides and get P is equal to 20 over 50 times 100. And once the 100 goes in 2 times, you end up with 40. So what percent is it? Percentage is, this is 40%. If you want to check yourself, 40% of 50 times 50, what does that equal? Well, 40% would be 0.4 times 50. And if we think about this, 4 over 10 times 50, the 10 goes in here for a 5. I multiply and I get 20. So 40% of 50 is 20. And that leads to the second way to do a problem like this. Just read and then put things in. 20, here's the number 20, is equal sign. What percent? I don't know. What percent of, multiply 50. So what I've done is I've created an equation. So the first one is proportions that we've already seen before. That's from chapter 6. The second one is a little bit more algebra, because we're making an equation that isn't really made of two ratios. Okay, so here now you could go through and simplify. Well, 50 over 1 goes in, so I'd end up with P over 2 equals 20, because the 50 goes in 2 times. And then to solve this one, I'd multiply both sides by 2. That's the multiplication property of equality. And P equals 40. So I know my P over 100, so I have 40%. P is my percentage. Okay, so proportions, algebra. And again, when you think about this proportion right here, since we are dealing with percents, you will always have a percent with a 100. So that means I'm going to give you this piece. Then you'll notice, at least let me kind of circle it for you here in yellow, you have 1, 2, 3 other missing pieces. Every problem you have is going to give you 2 of those 3 missing pieces, and you'll have to find the 1. So it'll say 20 is what percent of 50? That's a common type of problem. The other types of problems you could have is, what is 30% of 50? Okay, so now I don't know the what, but I know 30%. So again, I know the percentage, and it's out of 50. So I know all of these, and I'm missing the starting point. Okay. And the last one is 20 is 30% of what? So really, these are the 3 types, because in these proportion problems, there's only 3 possible missing pieces. And so basically you kind of move where is the missing piece for whichever these components you need. All right. So lastly, let's take a look. There is this kind of a percentage bar, if you will. Percentage bar goes out here to 100%. And so what we have down here is percents on the bottom, and we have the values on the top. Okay. And so it's out of 50. So we put 50 here. 50 lines up with everything because it's out of 50. And then as you break up your percent bar, you can have one, and usually they'll give these, if they give these to students, they'll already have the pieces broken off here. And so yeah, this would be 0%, 10%, 20%, 30, 40%, 50, 60%. I'm not going to put all of them in 70, 80%, 90, 100%. Ah, got it. Okay, so let's I have drawn my little tick marks in ways that don't match up perfect. So all I'm going to do is this. I'm just going to make a white pen, and I'm just going to draw over this stuff, and we'll just pretend that it was never there. Whee! Okay, there we go. Look at that. Yep. Oh, look at that. Perfect drawing. That is ideal. So learn from my mistake, which is as you're doing these, don't put your numbers in until you get your pieces in there. Okay. So let's see here. Now we had 50. So if I think of 50 over here, you can think of each percentage of 50. So this would be 0. And over here, 10% of 50 would be 5. 20% would be 10, 15, 20, 25, 30, 35, 40, 45, 50. Another question was 20 is what percent of 50? So if that was still your question, you build this chart, then you look where is 50%? Or sorry, where is 50? 50 is up here. Where is my 20? My 20 is here. It matches up with 40%. So 20 is what percent? It must be 40%. That matches up right here. So that again is known as a percent bar. Okay. So as you take a look at, if you were using percent bars, and again, there's nothing wrong with them as kind of a starting point, just make sure as you're using percent bars that you label what you know. And if you are looking at these effectively, and this is why I want to tie this back into chapter 1, you are creating an arithmetic sequence. Now, these fraction bars, in this case, they are technically fraction bars, but we'll call them percent bars here. They are fantastic if the number fits perfectly at a 10, a 20, a 30, a 40, or a 50, or something like that. Okay. Because when you make your arithmetic sequence and you say here over here, I have 70, that means 10% is 1/10 of it. So move the decimal and I get 7. And now I just create an arithmetic sequence to build all the other numbers. So it starts at 0, goes to 7. The next one's going to be 14. The next one's going to be 21. The next one's going to be 28. Oh, that's the piece I was missing. My answer is 28. So again, are there good things about the percent bars? Yes, there are. They're very visual. They're hands-on. What's the drawback? If the answer turned out to be 41.375%, your percent bar is not going to do a great job of helping a student solve for that. So in terms of kind of when do you want to use these, maybe at the beginning to kind of help students see kind of proportions, because really what I want you to see here is that you really did build a proportion. Take a look at this. You are saying 28 is to 70 as 40 is to 100. That's really what we're saying as ratios. Okay. That also is another way of saying 40 over 100 is 40%. Remember, per 100 means percent. All right, let's move on. And you can see them draw here. Here is the proportion model. And then they'll solve it using, in this case, they have cross multiplied. I still don't understand why they keep pushing that technique. You have x by itself and it's divided by 40. If you could undo multiplying by 40, x is by itself in one step instead of 2 steps. Yeah, I still don't understand. Okay, let's see here. In a class of 30 students, 60% are girls. Okay, well, what does that mean? 30 students is my total. So my total over here would represent 100% of the class. I don't have 100%, I have 60% of the class. How many students are girls? You could use the percent bar if you wanted to. Again, they've chosen a really nice percentage. If they said 57%, we're in trouble because it will not work well on the percent bar. But if you know 60% are girls, then just write 60%. 60%. Your class is out of 30 students. So out of 30 students, how many are girls? The number of girls out of 30 is 60%. Now for me, I would just multiply both sides by 30 so that I could get G all by itself. And 30 becomes over here, 30 times 60 over 100. I would simplify before I multiply, but I know some of you don't do that, so either way works. 100 is like 10 times 10, so 10 goes in here 6 times, 10 goes in here 3 times, and I get 3 times 6, so I get 18 girls. Okay. Now the proportion here is a little strange because it looks like 30 out of 100. I'm not a fan of setting it up that way, but you could certainly set it up as x over 60, 30 over 100. But really, if you think about 60 being the percentage, you're almost better off thinking of 60 out of 100, which would be 60 out of 100 is x out of 30. Will you get the same answer both ways? Yes, you will. That's completely up to you. However, what's strange is when you set proportions up so it's part to part instead of part to whole, it will create issues, I think, because students will be looking at this and saying, why is this one over here 24 out of 28 set up as part to whole, but the other one up here was part to part? And so it just seems a little strange. So I prefer the consistency. Is what is your percentage score? Take it x out of 100. And here they've listed it as 85.71. But really, if you were writing this out and I said, what is the exact value? Then you'd have 20, let's see here, 2400 divided by 28 is equal to x. Now, again, if I was doing this, try to make the numbers as small as possible before I try to do the simplify before I multiply or divide. And yeah, I probably wouldn't have even done that. Okay, I'm going to rewrite this problem just to kind of show you. Oh, WWSD, what would Scott do? Let's take a look. So I've got 24 out of 28 is some percentage out of 100. And first off, I would have simplified. I would not have done that cross product stuff. I would have simplified and I would have multiplied. So yes, I probably would have multiplied by 100 here on both sides. If you want to put it over 1, you can, because that's going to eliminate it, and you've got x all by itself. And then over here on this side, 28 is 4 times 7. And 4 goes into 100 25 times. Okay. So 25 times. That's what I would do. That's me, because now I've got a smaller number to divide with, which is 7. Okay. And to me, 7 is much easier to divide with than the others. Let's see here, 25 times 24. Now, I could come off to the side and do what many of you probably do, because you would just start multiplying. Hey, don't let me stop you. But if you really look at these numbers, you could rewrite them, because you know that 24 has a 2 in it, and 2 times 25 is really quickly 50, and that's much easier to multiply with. So me personally, I probably would have rewritten those and said that's the same as 12 times 50. That means I took half of this one and I doubled this one. And going over here, if I was to say, which of these would you rather do? You might say, oh, it's easier to multiply by 50. And if you happen to catch it, if you happen to, you might notice that 12 has a 2 in it, 2 times 6. So you could do this again and get 6 times 100. Again, take 1/2, double. So at the end of the day, without doing all of this additional work, I could come up with 600 over 7. Okay. So again, you could absolutely come over here, multiply, and get 600. That's fine. The numbers might get bigger. If you can see something that saves you a decimal place or 2 decimal places, I recommend that you do it. What else could you have done? You could have seen this as 4 times 6 on top. This is 4 times 7 on bottom. You could cross off the 4s, pick up the 6 here, and 6 times 100 gets you 600 as well. So you still get 600 over 7. Now, as I do the division, 7 goes into 600. How many times? 0 times. 8 times 7 is 56, gives me a 40. Times 5 is 35, minus equals 5. And that's it. I'm to decimal land right now. So you could either continue dividing to get n in a decimal that continues, or you could write it as a fractional percentage. So what would your final answer be? X would be 85, and 5/7%. That's what I probably would have written down. However, if you really are feeling eager and excited, go ahead and write it all the way out. 5/7. If you do this division, 7 times 7 is 49. And this is the one we saw in class with the beautiful little bracelet that you made, or at least I hope you made. 7.1428.5%. Either one of these would be perfectly fine as your final answer. Now, if you go back and take a look at what the book had down, they said, it's about 85.71. All right. Yeah, it is about 85.71. But you should be able to find the exact value. Next page. So here we go. Even with this percentage bar, you'll notice they say it makes up 21% of the zoo animals. How many animals does the zoo have? 21%. There's the 100%. How many total do they have? You know, 84 is 21%. So the bar isn't utilized to actually find the solution. The bar is set up to find kind of a way of building it up. And what's interesting is the technique that has been used with percentage bars matches what we were doing for partition division. So you know 21% is 84. So what you do is you divide by 21 to get 1%. So that becomes 84 over 21. And then you need to scale it up because you want to know how much the total is. So then you multiply by 100. And so that's why you see this approach here. 100 times 21 over 84 over 21, which gets you to 400. Okay. You could set it up this way as well. I'm not a fan of this approach. I kind of prefer you have 21%. That's 21 out of 100. You have 84 animals out of I don't know how many. And then here, if it was me, I would invert because that puts my variable on the top and then multiply by 84. So I have 84 times 100 over 21, and that equals x. And when you do that, you get exactly the same thing. You can kind of see you get exactly the same thing no matter which way you do it. Okay. Okay. Let's see here. So we can continue doing this for many, many, many questions. They say they're on sale for this much. The original price was this much. What percent were they discounted? Yeah. Yeah. I don't I would really love to get you to a place where you can see how all these are connected. I think I'm going to do that. Yep. So what I'm going to do is I'm going to show you how these all tie back to our multiplicative identity element, which is the number 1. Okay. And let's see here. It kind of goes down here as well. So this I think will be very, very helpful for you if you consider kind of how sales or purchases or increases, they all tie back to the number 1. You multiply by something bigger than 1, it gets bigger. Multiply by something less than 1, it gets smaller. Okay, so let's take a look and see. So again, 476 and 560. I'm going to jump into another page. So I have $476, right? Original, this is the sale price. Original is $560. So grab your calculator. Okay, do this one with me so you can kind of see where I'm getting these numbers from. And I will grab my calculator as well. I want you to take the original is this. Okay, so you are always paying some part of the original. So take the original to be your denominator, and then take 476 to be your numerator, and type that into your calculator. Okay, 476 out of 560 is equal to, let's see what you come up with. Type it in, press equals. Okay. So now take a look, right? You originally would have paid $560. Right now, you're being asked to pay $476 because it's on sale. What you are asked to pay is 85% of the original. If the sale was not going on, you would have paid 100% of the original. So if you divide this out, you can actually see what percentage you have to pay. If somebody asks you what's the discount, your discount is always going to be compared to what would happen if you didn't have to pay. So the discount is 15%. So now let's do another one of these. Let's say price was $20. Let's say $20 price. And let me just erase those pieces there. $20 price. And a store is going to mark something up. Marked up to, what do I want to say? $30. Okay, they mark it up to $30. So if I mark it up to $30, my original price was 20. You now have to pay 30. If you do this division, you end up with 1.5, which if you turn it into a percent is 150% of the original. Now remember, if there was no markup, you would have paid 100% of the original. So when you're comparing it, you can almost immediately see this is a 50% increase. Okay, they marked it up 50%. Okay. All right, let's try another one. Your turn. Try this one. Original price is 20. New price is 25. What is the percent change? Okay. So again, if you start with the original and you're trying to find the new, so start with the original would be down here on the bottom. Your new would be 25. Grab your calculator. Just do the division. 25 divided by 20. Now you can tell already 25 is bigger than 20, so the answer had better be bigger than 1. So here we go. 1.25, which is 125% of the original. Now remember, 100% would be my base, and that's where we can come up and say, aha, so that means a 25% increase. And that is what we have. I'll put it down as a plus 25%. Okay, they added 25% on. Now here comes the fun part. What if we decide to go backwards? $25. And now, right, you marked it up for a while to try to make a profit. Nobody's buying it, so you got to mark it back down. What would this markdown be from $25 to 20? Now remember, it's going to be tempting to say, oh, well, it was a 25% increase, so therefore, to go back, it must be a 25% decrease. Let's check that theory. So what we're going to have to do is put our original down as 25, our new price as 20. We grab our calculators, and we do 20 divided by 25. Now again, 25 is bigger, so 20 over 25 should be less than 1. So hopefully you got 0.8, which is 80% of the original. That means there must have been a 20% decrease. Why? Because we're always comparing it back to this number, which would have been 100%. So you're comparing it to 100% of the original, which would be what you'd have if you didn't change anything. But since you did change something and you have less than the original, I must have subtracted. So this is a minus of 20%. Sometimes this is a challenge for students because they'd like the percentage. If you go up with a percentage, you should go down with a percentage. And you do. The issue, and I hope you can kind of figure this out from our use of fractions too, is the original value that we're basing our percentages on has changed. One time it was 20, one time it's 25. So to get the same $5 change, which is what really we're looking at, a $5 increase or decrease, that is a percentage of the original. And that's why your percent change is not the same. Okay. So now, if you wanted to take a price, let's say the price, I think there was a question in the homework from chapter 6 that said you want a 1/10 of your salary increase. Well, 1/10 is 10%. If you want a 10% increase, then you start with everything you made before and you add 10% and you end up with 110%, which again, you should be able to look at as everything I started with plus 10%. So if you were looking at that and say, what's my salary today? My salary today is 50 grand and I want a 10% increase. The traditional approach in American schools is to say, multiply this by 10%, get that value, then take 50,000 and add whatever you just came up with, and that gives you your new salary. And I'd like you to see that this means you have to multiply. First, you have to type 50,000 into your calculator. Then you multiply by 10% and you get a number. Now, either you retype that number or you keep the number on your screen and then you retype 50,000 again and you get your new amount. Okay. But you could have said, hey, wait a minute. This is 50,000 times 0.10. And I'm adding 50,000 again. Maybe I could use our best friend of the distributive property and say, hey, I've got 50,000 here twice. It's separated by addition. Why don't I pull that 50 grand out? What's left will be 0.10 plus 50,000 divided by 50,000, which is 1, which becomes 50,000 times 1.10. So if you start at 50,000 and you want a 10% increase, multiply by 1.10 and you will be there in one step. 50,000 times 1.1, and that becomes 55,000. Now, if you want to do it again, you say, well, I want to get a salary 2 years down the road. Fine. You could take your 55,000 and multiply by 1.10 again. So take this and multiply by 1.10, and all of a sudden you're at 60,500. And you could do it again. You could say, what is it 1 more year down the road, right? So again, I get a 10% increase each time. Just again, on your calculator, you might even be able to just press the equal sign. Now all of a sudden we're at 66,550. So I can track that very quickly. And because I know about exponents, since I'm really just multiplying by 1.10 over and over and over again, I could have started with 50,000 and multiplied by 1.10 times however many increases I want as an exponent because it's repeated multiplication. So if you wanted to, you could actually grab your calculator and check this. Let's do it all in one step and let's do 3 years. Then come back to your calculator. I got to tip my calculator sideways here. Thank you, calculator. Let's clear that off. I type in $50,000 times 1.10 raised to the third power. I press equals and I get 66,550. And holy cow, that is very fast. Okay. So again, if you were doing it the old way, you would have to multiply, then you'd have to retype and add. Then you'd multiply, retype, and add. Multiply, retype, and add. It becomes a real pain. It becomes a real pain. So again, this is a really nice and fancy way to do this. The same is true for discounts. So let's say you were shopping, you saw something priced at $80, and you said, oh, it's 20% off. The real question typically for people when you go shopping is how much do I have to pay? Yes, I know my wife, when she goes shopping, she comes back, look at how much I saved. Oh, hold on here. How much did you have to pay would also be helpful to know. So 20% off. Always think about the whole amount being 100%. So when somebody says 20% off, think about 20% off of 100%. So that means instead of, again, here's the long old way, you would multiply this by 20%, get a number. Then you'd take 80, and because it's 20% off, you would subtract whatever number you just got and get your end result. Okay? Not that that's bad, but 20% of this becomes what, 16? Then you have to go back and you type 80 minus 16 in your calculator. Or if you're smart, you type 16 minus 80 and you get a number that's negative, but you know to take the opposite because you were doing it backwards to just try to be quick. Your end result would be $64. But if we use a little bit of thinking here and we say 80 times 0.20 is being subtracted from 80 itself, and then we use our amazing distributive property, we could rewrite this as 80 times 1, which is 100%, the whole amount, minus 0.20, which is 20% off, and end up with 80 times 0.80. My goal for you as future teachers is to see how powerful it is to just say, if I have 20% off, then that means I am paying 80%. Okay. Now you have one multiplication to do. You can do this in your calculator, or you could, honestly, you could rewrite this into fraction form if you wanted to, but totally up to you. Yeah, because multiplying 80 is 8 times 10. Put a 10 over here, you get 8. 8 times 8 is 64, and that's my end result. Most of you have your cell phones on you. If you're going out and there's like a store sale that says, 30% off, you can now, instead of multiplying by 30% off and seeing how much money you save, a bigger, quicker way would be to say, how much am I going to spend? Because that's kind of how things work in the real world, right? You still have to pay for things. So, all right, let's jump back over and make sure we've got this down, right? So the textbook approach, not wrong. Not wrong at all. You can find the amount of the discount, then divide. That's perfect. But you could just not find it by having to do this subtraction, right? If you look and say, here's what's on sale for, here's what this is, they had to do a subtraction first, then a division of those two numbers. You could just divide the numbers and find that percent discount without doing any of that in the middle. I hope you see that that is extremely efficient because it's massively efficient. So anyway, and you can see them kind of going through and doing this calculation. It's long. Look at this. The total percent discount is calculated by finding the total dollar amount discounted first. So they take how much did we take off and just divide by the original amount. No, please don't. Please don't use the techniques that I'm showing you because it does make it a little bit easier. And maybe we'll even do a couple of those when we do some of the practice for homeworks. Let's see here. Mental math with percents. Percents are great, but oftentimes it's quicker to think of the percentage parts as fractions. While it seems weird, the fractional pieces are oftentimes much easier to work with. And that's because they don't include a lot of decimals. So if you're taking 50% off of something, really 50%, you're not going to multiply 0.50 times 80. You're going to take half of 80 because you're thinking of it as the fraction equivalent. Couple other pieces that I know sometimes people get a little weirded out by, especially if they don't know the percentage, but you can use the commutative property. So let's say that I have, I want 78% of 50. This is one of my favorites. I love this one, right? So 78% of 50. Most of the time you're like, oh, I don't know, 78%. It's not a good fraction. So they just start multiplying. But remember what this represents. Of is the multiplication. So we're multiplying by 50. 78%, write it as a number, 78 over 100. And now use the commutative property of multiplication. right? So this becomes 50 over 100 times 78. And that's 50%. So what you've really done is you've said, guess what? 50% of 78 is exactly the same thing as 78% of 50. And by switching those around, 50% of something, you're like, oh, shoot, that's just half. Well, you can find half of something pretty quickly. But 78% of something, that's going to take a while longer. So again, keep this in mind. You can do this anytime for any of these kind of nice fractions to make it easier to work with. Okay. There you go. Kind of some fun tips, tricks of the trade, I guess, but they're not really tricks. It's just more of realizing that those properties are not there just to torture you. The properties are there to make your life easier. So Laura wants to buy a blouse originally priced at $26.50, now on sale for 40% off. She has $17 in her wallet. Huh. Okay. Well, if you're doing mental math, 20, let's see here, whoops. If you're doing mental math, write it down quicker in your head. 26.50, and we want 40% off. In my mind, 40% off means I am still paying 60%. So I would not write times 0.4. I would not. I just would not. I still would not. And then I would probably double one and half the other, so that now I would say this is 30%. I double this other one because it had a 50 cents on it kind of thing. And then I would work from there. So 26 and double is 52. Add another one is 53. So now I have 53 times 30. Now, if I want to estimate this, this is 30% is pretty close to a third. And so a third of 53, again, a little bit challenging to do. So I might do a third of 54, which would be 18. And say a little bit less than that. But from this quick estimate, I'd say she's in trouble. Yeah, not going to happen. Sorry, Laura. All right. So anyway, there you go. There's your estimating with percentages. Let's see here. Yeah, I think that's probably a quick way to go. What'd they say? It's easier to find 40% of 25. Okay, I guess. One way is to find 10%, then multiply by 4. Okay, again, I guess. But that again is just how much you have. Then you have to do a subtraction. I don't. This is an approach you can take. I'm not going to fault it. Maybe it's amazing. All right, so let's see here. Leonard got a 10% raise in the first year of the job, a 10% raise after another year. His total raise was 20% of his original salary. Again, you can check yourself. This is like an always, sometimes never. What? I mean, really. So if you were doing this and you said, I don't know what his salary was, but we'll call it S, and he got a 10% raise, but we know now that that's like 1.10. Then he got a 10% raise again. So basically that's squared. The question for you is this piece that we come up with, is this the same as his salary multiplied by 1.20? And the way you check it is by multiplying 1.1 times 1.1. And if you do check this, you end up with 1.21. And that is not the same. So which could be true? Is this always true, sometimes true, or never true? This is never true. I'm sorry. And the reason is the second raise that he got was not on his original salary anymore. It's a raise on his new salary. So if you get a 10% raise, it's always on whatever your new base is. So that is not correct. Okay, and they go through some of those. Look at that. He received a 21% raise. Yep. Let's see, you're computing interest. So they do give you a little bit of interest. The typical formula for simple interest is interest is equal to principal times rate times time. And if you want to find the total amount, it's principal plus interest. Like when you invest, you get the amount of interest you had and they add on the principal. So that's your total amount in the bank account. There are going to be a few questions about that. Just realize If they give you different time periods and they give you a percentage per year, make sure that you take the number. If they give you days, take it as a fraction of a year. So 90 days would be 90 out of 365. Okay. Find the interest rate if a principal goes up to this. Well, if a principal amount goes up to this, the amount of increase is your interest. So you have $900 in interest. And you can just rewrite it. What percentage times $10,000 gets you to 900? And again, they could write it the way they've written it. I think it's easier personally to rewrite it as a proportion. I made $900 in interest off a balance of 10,000. What percent is that? Multiply by 100 on both sides. And even honestly, I would simplify this a little bit, right? 900 over this, 2 zeros go away. I get 9 over 100. And honestly, I could actually solve this problem right now. I wouldn't have to do anything, right? 9 over 100 equals what over 100? Okay, 9. So my interest rate is 9%. I love when you can kind of see things. I mean, that's why you kind of take a step back and you don't just start doing things. Take a moment to look at it and think. And okay, boom, there we go. So that is it for 7.4. Hopefully these tips are going to work with you. I think they're really beneficial. And we'll kind of take a look and see, like if you had an increase of 5%, what would it take? What kind of a decrease would get you back to your starting value? If you had an increase of 10%, what kind of a decrease would get you back to your starting value? Those are percent increase and decrease questions that are very thought provoking. So hope that helps. Let me know if you have questions. All right, off you go.